Okay, hi class. Please settle down. Okay, we're gonna start soon. Okay, first of all, can those at the back hear me? Good, Okay. Okay, welcome to the first lecture of CS 2010, Data Structures and Algorithms 2. Okay. So this will just be more or less an intro lecture. Okay. So the content proper will start next week. Okay. Okay, so introduction of staff. This is me. Okay, this is your lecturer. Okay, I'm Chong Ket Fa. Just call me Ket Fa. Okay. So my office, my email is there. Okay. Obviously, I can't take all of you on by myself. Okay, so I'll have a lot of help. Okay, from your seniors. Okay, most of them have taken this course. Okay, so now they are your TAs. Okay, let's look at your lovely TAs. Okay, so these are all your TAs. You can go to IBLE, look at their lovely photos, get to know them. Okay, so you will get to know them very well, okay, throughout this course. Okay. Okay, so outline for this lecture. Okay, some course admin stuff. Okay, and then after that, a quick review of what you have learned in 1020. Okay, and comparison with what you will learn in 2010. Okay, after that, I'll talk about the contents of a brief overview of the contents of 2010 with respect to several different problem-solving paradigms that you will be seeing. Okay. Okay, first of all, assessments. Okay, how will you be assessed? Yeah, what is your CA made up of? Okay, basically, it's like this. The breakdown is like this, as stated here. Okay, tutorials, lab participation, attendance, 6%. Okay, 3% each. Okay, and then you will have regular programming exercises, or what we call problem sets. Okay, they'll take up 24%. Okay, there'll be 2 written quizzes. Okay, make up 20%. Okay, one is 14%, one is 6%. So there's a big one and then there's a small one. Okay, then there'll be 2 online quizzes. Okay, and then finally your final exams. So you have a lot of assessments, which is in a way good, in a way bad. You might think that there's a lot of work, but then that also means that you have a lot of chance to get to score. Okay, yeah. Okay, so all of the assessments will be open book. Okay, your written quizzes, your online quizzes, your exams will be open book. Okay, but open book does not mean open internet. So no internet allowed. Okay, but you can bring any book, any written stuff into the hall. Okay, for your written quizzes, online quizzes, final exams. Okay. Okay, let me talk a bit more about your problem sets. Okay, these are more or less bi-weekly affair. Okay, they are going to be 6 problem sets. Okay, most of them are sort of related. Okay, and they use real life examples. Okay, but they are a bit exaggerated lah. Okay, a bit exaggerated. Okay, each of the PSs will have the same weightage, about 4% each. Okay, and this one is not inside your lectures because in the previous semesters, students keep asking me, how am I going to be graded? Okay, so I didn't put it in, so now I'm going to put it in. So basically, your PS is a subtask-based system. Okay, so it's one simple problem broken down into many subtasks. Okay, so each subtask will have some marks. Okay, so if you pass all the test cases for each subtask, then you get all the marks for it. Okay, it's that simple. Okay, but for the highest subtask attempted and failed, that means that you don't pass all the test cases for that subtask, right? Then your lab TAs will do manual marking. Okay, and for manual marking, it will be a very strict affair. Okay, it's a very strict criteria. Your program must be very, very close to the correct solution. Okay, meaning that the algorithm must almost be correct or correct, but then you made some mistake in the implementation or you gave an inefficient implementation. Okay? So if that's the case, then you'll get 1/4 of the marks for that subtask. Okay? So either you get full marks, you get 1/4 marks, or you get no marks for that subtask. Okay, that's how you'll be graded. Okay? Okay, some rules for your PSs. Okay, you are allowed to collaborate. Okay, I allow you to discuss with each other. Okay, but you are only allowed to collaborate at the algorithmic level. Okay, but you have to write the solution yourself. Okay, so basically everything in this course will be based on Java. Okay, which you have learned in 1020. So you'll carry over here. I assume you all know Java. Okay, who don't know Java? So you didn't take 1020? Oh, exchange students. Okay, some of you are exchange students who don't know Java. Then I will suggest that you have to learn it on your own. Okay? Yes. Then try to catch up. Okay. Can be done. Can be done. Okay. If you would like, you can approach me later. I can give you some materials. Okay, for learning Java. Okay. Okay. So that means you cannot discuss, show, or copy each other's code. Okay, that's a no-no. Okay, you cannot do that. Okay, you can post algorithmic ideas, data structures to our Facebook group. Next, later on I'll be talking about the Facebook group. Okay, but you can never send Java code to anybody. Okay, even if it is a buggy one. Okay, so like I said, you have to write and debug your own Java code. Okay, looking at your senior's code is also considered plagiarism, so don't look at your senior's code. Okay, and we'll be using CodeCrunch for this, so all submissions are recorded. Okay, I have some students who try to take their senior code, submit it, and then later on modify senior code and resubmit it. Okay, you can check all your history. Okay, how come this one, I've seen this code before, that means plagiarism. Okay, so don't do that. Okay, so we have a plagiarism checker also. Okay, so some of you also use some kind of repository like GitHub, okay, or Idea One. So if you put your stuff there, please make it private. Otherwise, other students can accidentally get it from you, and then when I find that, how come these two codes are the same? Then you also get it, right? Okay, so yeah, like that. Okay, you can see it. Okay, so in a nutshell, for your PSs, I allow you to collaborate, help each other, but only at the algorithmic level. Okay, so helping is not cheating. So don't help each other write code. Okay, the purpose of your PSs is basically to allow you to implement code. Okay, to train you to implement algorithms. Okay, so that you have to do on your own. Okay, so a bit more. Okay, PSs, like I said, it's one simple problem broken down into many subtasks. Okay, each of them having gradual level of difficulty. So the easier subtasks will probably require only 10, 20 knowledge. So that's quite easy. And most of the other subtasks will require 20, 10 knowledge. And then the last subtask, okay, is the harder subtask. It will probably require more creative use of your 20, 10 knowledge or even higher knowledge. Okay. So we will not throw you into a deep end. Of course, we'll give you some help. Okay, so the idea, but not the Java code, okay, for solving the first one or two subtasks will be discussed during tutorial. Okay, so you can score up to about 50 marks if you understand what is being discussed during tutorial. Okay. Next, the implementation of the required technique, but not the actual solution, okay, will be demonstrated during lab. So if you understand what is being demonstrated, I can apply this to solving my problem, then you can get about 75 marks, okay, out of the 100 marks. Okay, and the last subtask will be usually quite hard. Okay, it's either very difficult or it's very tedious to implement. Okay, so if you want to aim to solve this one, then you must be prepared to spend many hours trying to program it. Okay. So if you aim to get A or A+, then please do the last subtask. Okay. Otherwise, I will still encourage you to attempt it because it will be very helpful to your learning also. Okay, but Since this is not the only module you take, you have other modules, right? So please manage your time well, okay? Okay, so in picture form, this is probably the amount of time you need to spend. Okay, first subtask, you get up to about 40, 50 marks. 1 or 2, 3 hours. Okay, that's simple. And up to 75 marks, probably 4, 5 hours, 5, 6 hours. Okay, and then doing the last subtask. Okay, more hours, maybe up to 10 hours. And sometimes for harder PSs, the last subtask will be like this. Boom. Okay, you go up. It's like an exponential curve. Okay. So you might need to spend a few days trying to solve it. Okay, next, written assessments. Okay, you have your written quizzes, makes up 20%. Okay, quiz 1 will be the bulk of the percentage. It's 14%. It's on the 6th week. Okay, 6th week means the last week before the recess week. Okay, before your break. Okay, so it's on Friday, 22nd of September. So do not go on holiday on that Friday. Okay, do not go on holiday. Okay, block it out for your midterm. Okay, the second quiz, which will only be 6%, it's a very short quiz. It's more like a spot quiz. Okay, so this one will be during the lecture on the 12th week. Okay, so it's just a very short one to prepare you for the final exams. Okay. So I would say that PSs, okay, deals with your ability to come up with and implement the algorithm, whereas the quizzes, final assessments, it deals with your ability to model the problem correctly and then come up with the algorithm to solve it. Okay, so for your written quizzes, I don't expect you to write code. Okay, you can write pseudocode. Okay. Okay. Next, you have 2 online quizzes. Okay. Quiz 1 will be on the 6th week, and quiz 2 will be on the 11th week, both during your lab. Okay, both during your lab. Okay. So your online quizzes are basically simpler than your written quizzes. They test your basic to intermediate knowledge of the material. Okay, so how will we conduct the online quizzes? Okay, that will lead me to introduce the IT tools that you will need, okay, for this course. Okay, the first one is Visual Algo. Okay, this will be heavily used during the course. Okay, it's basically a tool developed by Dr. Stephen Halim, who is my predecessor who taught this course. Okay, he's the one who developed the tool. Okay, it's basically a tool to visualize algorithms and their structures. Okay, and his ultimate goal is to automate learning of their structures and algorithms. Okay, so no lectures. That means that I'll be out of job and he'll also be out of job. So he created a tool to make himself out of a job. Okay, but we are still a bit of a way off, okay? So we are not quite there yet. Okay, so let's look at it. Let's introduce the Visual Algo. Okay, so you can go to the page here, visualalgo.net. Okay, you can select your language. There are a few different languages currently. Okay, so you'll see that there are many topics here: sorting, bit mask, linked list, hash table, binary heaps, etc. So just click on the topic that you're interested in. Okay, for example, linked list. Okay, once you go in, you'll find that there are actually 2 modes. Okay, the default one, once you go in, is called the e-lecture mode. Okay, so you'll see a lot of words here describing linked list, okay, how it works, okay, how to implement it, and things like that. Okay, then you can do page up, page down to go through the contents. Okay, and then there are also example animations, okay, to show the operations on the linked list. For example, this one, search for 77 in this linked list. Okay, click it, and then you'll see animation on how it's done. Okay, so this one you can explore on your own. Okay, this is the e-lecture mode. Okay, it's more like a guided tour of the topic. Okay, you can consider a more wordy version of your PowerPoint slides. Okay. Next, there is another mode called the exploration mode. You press escape, then you'll be in the exploration mode. Okay, in this mode, you can freely explore linked lists or whatever topic that you choose. Okay, so here you can try to create empty linked list, a random linked list, etc. You can do searching for some item in your linked list. Okay, insert an item into your linked list, remove some item from your linked list, things like that. Okay, so this one you can explore on your own. Okay, let's go back. Okay, so as I said, Visual Algo will be heavily used, okay, for this course. So if you want to follow along, bring your laptop or tablet. Okay, currently it does not work very well for small iPhones. Okay, so I think the bigger iPhones will work lah. Okay, the plus size iPhone, the small one I'm not sure. I think it will. You have some drawing problems. If I can try it out. Okay, so we'll use less static PowerPoint slides. Okay, instead we'll rely a lot on Visual Algo. Okay. Okay, next we also use Visual Algo as our online quiz tool. So how will we do that? Basically, we will make use of this feature called the training mode. Okay, this training feature. Okay, let's show this. Okay, if you go to visualalgo.net/training, again you'll see all the topics that you have, and then you can select topics to be trained on. For example, I want to be trained in recursion, linked list, sorting, hash tables, etc. So just click them, and then you can set the question difficulty, you can set the number of questions, you can set the time limit. Okay, and once you go, you press start. Basically, you'll start your training where there's a pool of questions. Okay, already in Visual Algo, you randomly pick questions from there based on the topic you select. Okay, and your online quiz will basically be using this feature also. Okay, we'll be using this feature. Okay. Right, let's go back. So if you train hard enough, okay, if you train hard enough because it's randomly selected, right? After a while, you will have seen all the questions in the pool of questions. Okay, then you can score for your online quiz. Okay, so this is for your machine graded part 10%. Okay, train hard enough, you can score. Okay, so finally, make Visual Algo your personal tutor. Okay, bookmark it, tell the world it exists. Okay, help us to give some free advertisement. Okay. Okay, next tool you'll be using, basically CodeCrunch. I'm sure most of you have used CodeCrunch. Who hasn't used CodeCrunch before? Okay, some of you haven't used CodeCrunch. Okay, I've included a guide on using CodeCrunch, okay, in the lecture notes package, so you can look at that. Okay, for the rest of you who have taken, I think 10, 20, you would have used CodeCrunch lah. Okay, so basically this will be the platform where I will release all your PSs, and this will be a platform where you will submit the programs for your PSs. Okay. Okay. In fact, PS0 is already up on CodeCrunch for you to try. Okay. PS0 is not graded, but then you will see sort of the format of all your PSs if you try PS0. Okay. It's the same kind of format. Okay. So let's look at PS0. Yes. Okay, yes, if you find that you have no browse button, right, that means that you must enable Flash Player. The browse button depends on, is a Flash Player object. So enable Flash Player for CodeCrunch. Okay, if you don't want to enable for any other website, it's fine, but you must enable it for CodeCrunch. Okay, otherwise you can't see a browse button. Okay, so that is one very common error that will happen if you don't enable Flash Player. Okay. So if you look at the guide, the CodeCrunch guide, I included it inside the guide. Okay, inside there. Okay, let's look at PS0. Okay, so you will get an idea of how your PSs will be like. Okay, so if you click on PS0A, okay, the first subtask here is the description of your problem. So it's very simple, problem description. Given two integers, just sum them. Okay, so there's a time limit 1 second. Okay, so the input, each line of input is one test case on its own. Okay, each line contains two integers a and b. Okay, which is between 0 and 2 to the power of 30 minus 1. Okay, and the input will be terminated by 2 minus 1s. Okay, so output, for each test case, output a line containing a single integer, which is the result of summing the two integers. Yeah? So you have a sample input, sample output, and we will give you a sort of skeleton program for you to use. Okay, so this is Java template. Okay, so here you see I have a class called addition as the main function, the main method. And then I have a class called integer scanner. So instead of using your normal scanner, I'm using an integer scanner here. Okay, so this is actually coded by one of your seniors many years ago for your use. Okay, so what's the difference between this integer scanner and the normal scanner? Okay, the analogy will be something like this. In a normal scanner, it's like someone, okay, for example me, I ask one of my TAs, please help me go to the canteen and buy Coke. Okay, then he'll go to the canteen, buy Coke, bring it back to me. And I say, please help me go to the canteen and buy, help me buy Korean food. Then you go to the canteen, buy Korean food, bring it back. And then after that I say, I'm still hungry, I want some snacks. Okay, please go to the canteen and help me buy some snacks. And then you go to the canteen, buy snacks again. Okay, that's how scanner works, right? You ask scanner, scan this integer, scan this, you will do that. Okay? For integer scanner, what it does is this. When I say, go to canteen, help me buy Coke. Okay, then the student will say, I go to canteen, I buy Coke, I buy Korean food, and then I buy snacks. And then I'll come back, and I'll give him the Coke first. After that, I'll say, hey, help me buy Korean food. You already bought it, right? So he just pass you the Korean food. And after that, he said, I want snacks. You already bought it, right? So just pass him the snack. Okay? So it's much faster, right? One trip to the canteen, come back, rather than multiple trips. Okay? That's the analogy here. It's buffered. Okay, this is buffered input. Okay, buffered scanning. Okay? Okay, so this is PS0 subtask A. Very simple, right? I believe most of you can do it in 10 minutes tops. Okay, finish this. Okay, next. So subtask B, slightly harder. Slightly harder. What's the hard part? Everything is the same except this. The integer now is from 0 to 2 to the power of 64 minus 1. Can you solve it the same way that you solve subtask A? Subtask A, you can use integer, right? Just use the integer type, correct? For this one, can you use integer type? What happens if you use integer type? Overflow, right? Because you might have a value, two values, which is 2 to the power of 64 minus 1. Get them together, store in the integer, overflow, right? Can you use long? I don't use integer, I use long. Can. Will it work? Long will still overflow. Why? What's the maximum long number? 2 to the power of? Yes, someone? Anybody? Anybody? What's the maximum long number? 2 to the power of? 2 to the power of 63 minus 1? Is it 2 to the power of 63 minus 1? Or 2 to the power of 64 minus 1? Okay, I also can't quite remember, but it's either 2 to the power of 63 minus 1 or 2 to the power of 64 minus 1, right? Correct? So if it's 2 to the power of 63 minus 1, you cannot even read in the value into a long number, right? If it's 2 to the power of 64 minus 1, yes, you can read two long numbers, but when you add them together, overflow. Correct? So either ways, you get overflow. Okay, so what can you do? You must use the big number class, big integer class, okay, in Java to solve this. Yeah. Okay, so this is a sort of a taste of your PSs. Okay, the earlier subtask easy, and then the later subtask harder and harder. Okay, so how is it harder? Either time limit. For the easier subtask, okay, the time limit is very loose. Okay, 5 seconds, something like that. Very easy. Small input size. Okay, very specific inputs. Okay, that you can easily compute. Okay, and then for later subtasks, very tight time limit. Okay, very general input, huge input size. So you must use better and better algorithm to solve it. Okay, so that's how it is. Okay, now, unlike for 1010 or 1020, okay, for 2010, no output will be shown when there's an error between your result and the expected result. Okay, those who know CodeCrunch, right, you know that actually there's a way to cheat in CodeCrunch. You don't know what's the test, you don't know what's the input, right? You can just print it out. Right? You just try to print it out and then it will show down there all the input, right? Right? Because you say error, okay, this is what it is, and this is what you print out is the input, but then this is the expected output, right? Okay, but here, no, you cannot see anything. Okay, all CodeCrunch will tell you is like this. Okay, time limit exceeded, memory limit exceeded, incorrect output, or runtime error exception. That's all you know. Okay, so you must debug. You must learn to debug on your own. Okay, you cannot rely on CodeCrunch to debug it. Okay, so learn to create good test cases. Okay, this is a very important skill. If you're able to create good test cases, it means that you actually understand the material very well. Okay, Anna? Okay, so that's it for the IT tools that will be used. Okay, next let's talk a bit about the module or how you should study to get the grade you want. Okay, for the module. Yeah. Okay, how to get B minus or B grade in 2010? Okay, not that hard, it's very simple. Just do the minimum requirements. Okay, and then get slightly better than passing for your written quizzes and exams. Okay, get about 75% for all your PSs. Get about 8 out of 10 for your online quizzes. And attend all your labs plus tutorials. Okay, I want to emphasize the importance of attending your labs and tutorials. Okay, why? Because I have a case of a student who is a very good student. Okay, he did very well. He should have gotten A or A minus, but then he could only get B plus. Why? Because he never attended any tutorials, he never attended any labs. So 6% gone. Okay, 6% is the difference between a grade. Yeah, so please attend. Okay, next, how to get B plus, A minus? Just do all those that's required for B minus and B. Okay, improve your mathematical proficiency. Okay, especially in the area of proof. Okay. And then occasionally complete the harder subtasks for PSs. So get full marks for some of the PSs. And occasionally be able to solve the harder questions in your written quizzes and final exams. Then you get B plus, A minus. Okay, A plus, also quite easy, just do everything with nearly perfect score. Okay, not necessarily, because the written exams are very hard to score full marks. Okay, so just score as high as you can for that. Okay, so if you get A or A plus, you are invited to take Dr. Stephen Halim's competitive programming course next semester. Okay, so these are for those people who really, really love programming and algorithms. Okay, so if after this course, if now you really love algorithms and programming, and after this course you still love programming and algorithms, right, and you get this high score, then yeah, take his course. Okay, take his course. Okay, next we actually have a discussion forum on Facebook, so we'll be using that instead of the IVLE forum. Okay, so please subscribe. Okay, please subscribe to the group. Okay, so yep, here's the group. Okay, this is the NUS CS 1020 group. Okay, so you can post any queries you have, okay, on that group. Okay, someone just joined. Okay, so all the discussions will be on this Facebook group. Okay, and since we have a lot of your seniors already there, it's a lot of people there already, so whatever question you ask, probably someone will be able to answer it. Okay, so this is called crowdsourcing for answers. Yeah. So if you don't have a Facebook account, create one. Okay, if you dislike Facebook, just create it for this module. After the end of this module, you can delete it. Okay, yeah. Okay, then what's IVLE for? It's basically just for publishing lecture notes, okay, tutorials, okay, announcements, and for your grade book. Okay. Okay, finally, the book, okay, the recommended or reference text, okay, for this course will be the Competitive Programming 3 book, again written by Dr. Stephen Halim. It's actually not a CS 2010 book, it's a CS 3233 book. Okay, but it might be very, very useful for your labs, okay, for your PSs, okay, and also it's a very good book, okay. It probably increase your understanding of a lot of the algorithms and data structures we deal with, okay, and it might be useful for tackling the sum of questions in your quiz and final exams, okay. It might be only, okay, so it's no guarantee, okay. So don't think that if I buy this book, then some of the questions will come from there. And then if it doesn't come out, then you come complaining to me, a refund. You know, it just might come out, not necessarily will come out. Okay, but it will be a very useful book. Okay, so I recommend it. And I will be selling the book today. I'm not selling it in the lecture theatre. I tried it last time, it was a mess. So I'll be selling it from 2 to 7. Come to my office, okay, which is here, COM 20266, okay, if you want to buy it. So it's just $22 per copy. Yeah, about 50 copies for sale. Okay, or if you don't want to buy it, you can try to borrow it from the Central Library. Okay, I don't know how many they have. Okay. Okay, so this is the admin part. Instead of taking a break, let's just continue. Okay, so let's do 1020 review. Okay, it's a very quick review. Okay, with the help of Visual Algo. Okay. So, as you know, CS 2010 is part of three modules that you have to take, right? Okay, so it's a trilogy. You start from 1010, then you take 1020, then after you take 2010. Okay, for the CS students at least. Okay, so this is a continuation of the stuff that you have learned in 1020 lah. Okay, in 1020, what do you learn? You learn Java, right? You learn OOP programming, and then you learn linear data structures. Okay, so now we have come to 2010. What you will learn is non-linear data structures. Okay, and we will continue to use Java, okay, as a programming tool, as a programming language. Okay, so you have learned object-oriented programming, okay, in 1020, okay, in Java. So you know how to write classes, right? For example, here I have a bank account class. Okay, so what does your class compose of? Basically data, right? For example, in your bank account, you have a balance, okay, for your bank account. Okay, this is the data, okay, which you call attribute or member, right? Member data, okay, in your class. And then you have the functions that operate, or the operations that operate on your data, right? Right? So you have the constructor, which allows you to construct an object of the class. And then you have your mutators and accessors, right? To mutate or change your attributes and to read, okay, return the results of your attribute, the values of your attribute. Okay? Okay. Let me use this one. Okay. So we will be using Java classes and OOP principles in our CS 2010 PSs. Okay, so we'll be using stuff like integer scalar, which you have seen just now, and things like integer pair and so on. Okay. Next, you have learned basic algorithm analysis. Yeah. So you know about the big O notation. Okay, which is basically, what is that? What's big O notation? It's the upper bound on the time complexity, right, or the runtime of your algorithm. Yes. Right. So example, this one. I have this code fragment here, sum equals to assign 0, and then I have a for loop here. Okay, for I assign 0, I smaller than n, I plus plus. Then you do something. Okay, what is the time complexity of this code fragment? Okay, this is just one statement, correct? Sum equals to 0 is just one statement, so it's one time. It's for loop. It loops from 0 to n minus 1, so it's O(n) time. Yeah. So altogether, this is a O(n) time algorithm. Yeah. Okay, so CS 2010, we will extensively use this kind of algorithm analysis, and we also learn a few more advanced algorithm analysis skills. Okay. Okay, next, you have learned linear data structures. Okay, so what is a data structure? Okay, in general, a data structure is basically a way to store, organize, and answer queries on data. The main theme is basically the management of data, okay, efficiently. Okay, so we abbreviate it as DS. So for a good DS, okay, you need efficient operations, right? Okay, to manage its data. So what are some of the operations that you need? Okay, you need insertion. Okay, you need an efficient way to add items into your DS. Okay, you need to search. Okay, for an item inside your DS, so you need to have efficient way to search for it. Okay, next you need to be able to delete an item, okay, from your DS. So remove an item efficiently. Okay, next, general queries. Okay, like how many items are there in your DS, what's the maximum item, what's the minimum item, etc. Okay, and then update your item. That means that update the value of the item. Okay, so either you can do search for the item, update the value, or what you can do is first delete the old item and then insert the new item with the updated value. Okay, that's update. Okay, so you need all these operations to be efficient for your DS. Okay, and different situations require different DSs. Yeah. So what are some of the linear DSs you have already learned? Okay, you have learned arrays. What are arrays? It's basically a DS which stores items of the same type, right? Okay, in contiguous memory, right? And it's fixed size. Yeah. Then you have also learned vectors and array lists, right? Which are basically arrays, but they are resizable. Okay, they are resizable arrays. Okay. Next, you have also learned linked lists. Okay, what linked lists? Yes, those who have done 2010. What are linked lists? Can you remember? What's linked list? It's basically a way of storing. It's a data structure that stores your items sequentially, right? One after the other. Okay, in the form of a node, right? And then a node will have a reference or pointer to the next node in the sequence, right? Yeah, and then they are not stored in contiguous memory. They might be stored in non-contiguous memory. Okay, so that's a linked list. Okay, next you have learned about stacks, which is basically a last in first out data structure. Okay, that means that the last item in will be the first one that goes out. Okay, you have also learned about queues, which is basically a first in first out data structure. The first one that comes in will be the first one that goes out. Okay, so in CS 2010 you will learn non-linear data structures. So these arrays, vectors, linked lists, stacks, queues, these are linear data structures, okay, that you have learned. So in 2010 you'll learn non-linear data structures, okay, like heaps, okay, binary search trees, union, find, disjoint sets, and graphs. Yes.
What defines a linear table?
Basically, you can view them as being stored in a linear sequence. Yes. Whereas if you look at heaps, binary search trees, and the rest graphs, they are not stored in a linear way. Okay. Can? We will talk about that more as we go through the contents of 2010. Okay, let's use Visual Algo to try to visualize some of the algorithms you have learned. Okay, for example, linked list. Okay, so this is a linked list, right? Okay, you have each item stored in a node, and then for a node you have a reference to the next node in the sequence. Yeah, that points to the next node in the sequence. Okay, so the first node is called the head, and then the last node is called the tail. Okay. So what can you do with a linked list? I can search for an item in the linked list. Okay, for example, I search for the value, search for the value 6. Okay, so how does that work? You start from the head, right? Yes. Start from head, then you will go down the linked list, right? By following your references. Okay, then you find, okay, 22 is not. The next one, go to the next one. 2 is not. Okay, go to the next one. 77 is not 6, right? Go to the next one. Yes, 6, you found it. Okay, so this is at index 3. So you can imagine that these are all indexed. Okay, head is at index 0, so 6 is at index 3. Okay, so you return 3. Okay, I found it at index 3. Okay. Next, you can also insert an item into your linked list. Okay, you can insert it at the head, you can insert it after the tail, or you can insert it at a specific index. Okay. For example, let me insert 90 at index 2. Okay. So what happens? So I'll start from the head, which is index 0, right? Then I'll keep moving down until I hit index 1. Okay? Then index 1 will be pointed to by a previous pointer. Index 2, which is the next node after it, will be pointed by an after reference. Okay? Then I will create my node, okay, which is 90. Okay? So this is pointed to by vertex. And then vertex will point to after. Right? And then after that, previous will point to vertex. Right? And so you have inserted 90 at index 2. Okay? So you can explore this on your own. Okay? Try all the other operations. Okay? And try all the variants of these operations. Okay? Next, you have got stack, which is basically in Visual Algo, you visualize it as the linked list implementation. Okay? So it's just turning it around 90 degrees. Okay? So the head is basically the top of the stack. Okay? Tail is basically the bottom of the stack. Yeah. So what the operations? You can create a stack. Okay? You can create a random one, etc. And then you can pick. Pick is basically just return the value of the top of the stack, which is return the value of the head. Yeah. Next, you can push a value onto the top of the stack, right? So just add a new value as the new head. Yeah. D3 becomes the new head. Okay. Next, you can pop. Pop will remove a value, right? Which value will be removed from the stack? Which one? The top one, right? So the head. Okay. So if you pop, you just remove 53. Okay. So now 22 becomes the new top of the stack. Yeah. Okay. Next, you have the queue. Okay, which is first in, first out. Just now the stack was last in, first out. Yeah. So this is the first in, first out. Again, you can imagine it exactly like a linked list, but you add it. When you add something, you add it where? You add it at the back, right, of your queue, which is the tail. And then when you remove something, you remove it from the head. Okay? So, same thing you can pick. So you just return the value at the head, which is the front of the queue. Next, you can enqueue, which is to add it at the back. Okay, so let's add 57. So 57 will become the new back of the queue, or the tail. Okay, next you can dequeue, so you just remove the head. Okay? And so this is a queue, quite simple. And then you have other variants like doubly linked list and double-ended queues. Okay, this one you can explore on your own. Okay. Okay, so let's come back. Okay, next, what have you learned? You have learned recursion, okay, or more advanced recursion compared to 1010. Yeah. So some of the examples that you have done is a countdown example, factorial, printing linked list in reverse order, towers of Hanoi, okay, and choose K, string permutations, etc. Okay, so these are some of the recursive examples you have seen. Okay, so in 2010 we will see much more recursion. Okay, much more recursion. Okay, but I won't go through recursion again. I will assume that you know recursion already. Yeah. Okay, again, let's try to visualize. Okay, you can use Visual Algo to visualize the recursion happening. Okay, so for example, I want to visualize the computation of the Fibonacci number. Okay, so how do you calculate the n Fibonacci number? There's a formula for doing it, right? What's the formula? So Fn is equals to Fn minus 1 plus Fn minus 2, right? Basically, the n Fibonacci number is the sum of the previous two Fibonacci number. Yeah. So the recursive code is very simple. So if n is small equals to 1, return n. Else return Fn minus 1 plus Fn minus 2. Right. So let's try to visualize a example where n equals to 5. Okay. So I click run. Okay, you start with 5, right? F5. Okay, F5 will call what? F4, right? Right? Then F4 will call F3, right? F3 will call F2. F2 will call F1. And F1 is the base case, right? So you return 1, okay, to F2. Okay? Now then you come back to F2, you will call F0, right? Okay. F0 is also base case, return 1, return 0, sorry. And so F2 will be 1, yeah? And 1 is returned to F3, right? Then F3 will call F1 again, right? Then this will be 1, and then this is returned to F3, F3 will be 2. Okay, add these two together. And then F3 will return 2 to F4, right? Then F4 will call F2 now, right? Then after that, you get the same thing, right? Correct. So call F1, then after that call F0, then you get 1, then these two will be returned to F4, so F4 will be 3. Yeah? And 3 will be returned to F5, F5 will now call F3. So after that, you see that this whole thing is repeated, right? Yeah. Okay, so F3 will be 2, and then 3 and 2 return to 5, so F5 will be 5. Okay, so you can visualize your recursion, okay, in Visual Go. Okay, so we have done this. Okay, next you have learned sorting, okay, in 1020. So you have learned big O of n squared sorts like selection sort, double sort, insertion sort. Okay, you have also learned big O of n log n merge sort. Okay, and also big O of n log n quick sort, expected quick sort, if the pivot is randomized. Okay, for the quick sort that you learned in 1020, where the first item is picked as a pivot, right? In the worst case, it's not n log n. It can be big O of n squared. Okay, because your partitioning can be completely skewed. Okay, but if you randomize the pivot, it's expected n log n. Okay, so you will probably deal with this randomized quick sort later if you take 3230. Okay. So in 2010, if not explicitly stated, you can actually use the Java API to help you do sorting. Okay, you can use collection.sort, okay, for all your sorting needs. Okay, but we also learn more sorting algorithms here, like heap sort or binary search tree sort. Okay, let's also try to visualize sorting. You can also visualize sorting in Visual Go. Okay, so here let's just do bubble sort. Okay, how does bubble sort work? Anyone can remember? Basically, you go down the array, right? You go down the items. So every pair, every adjacent pair, you just compare, correct? If they are out of place, swap them, correct? And keep doing this. Okay, 1 pass, 2 pass. How many passes do you need? N minus 1 passes, right? Correct? Yes? Yeah. Okay, let's try. Let's visualize this. Sort. Okay, so at the beginning, everything is unsorted. Okay, then after that, you will take the first two items or first two values, compare them. 3, 44, are they out of place? We are sorting it in ascending order, not out of place, right? Okay, move to the next two. 44, 38. Is it out of place? Out of place, swap it. Okay, then you go to 44, 5, out of place? Yes, swap it. 44, 47, not out of place. Okay, 47, 15, swap. 47, 36, swap. Okay, 47, 26, swap. 47, 27, swap. 47, 2, swap. 47, 46, swap. 47, 4, swap. 47, 19, swap. 47, 50, no. 50, 48, swap. Okay, so after one pass, this is one pass, you find that the largest item will be in its correct position. It has bubbled, okay, all the way to the top. Okay, that's why it's called bubble sort. Okay, then this is first pass. Next, second pass. Okay, you just need to go through this smaller array now, smaller unsorted array. Yeah, do the same thing. Yeah, go to them, every adjacent one, compare, swap them if necessary. Then the second largest one will be in its correct position. And then keep doing this, right? Okay, let me just do this very quickly. Okay, at this point, you see that everything is actually sorted already, right? Correct? So, you just need one more pass, right? One more pass, you go through everything, you find that during this pass, nothing is out of place, right? There's no sorting done. So you can actually optimize bubble sort to stop now, right, instead of going through all n-1 passes. Yeah. So everything is sorted. Okay, so this is bubble sort. Okay, so you can do the rest. You can explore the rest on your own. Okay, there's selection sort, insertion sort, merge sort, quick sort, and other kinds of sort. Okay. Okay, let's come back. Okay, next, you have learned hashing in 1020. Okay, hashing and hash tables. Okay, so what is hashing? What's a hash table? A hash table is basically a very efficient kind of data structure, right? Where you store each item as a key value pair, right? Key value pair. So you use the key to insert the value, you use the key to search for the value, and use the key to remove the value. Okay, very quickly, expected O1 time, right? So the simplest form of a hash table you have learned is the direct addressing table, which is basically just an array. Okay, so you use the index as the key, okay, and the value is stored at the particular index. Yeah. Of course, direct addressing table might not always be very practical. Why? Because your key values might have a very large range. Okay, so you cannot. Sometimes it might be bigger than the memory size you have, so you cannot create an array of that size. Okay, so what do you need? You need a hashing function, right, that maps the key to the index of your hash table. Okay, so you have learned how to create good hash functions. Okay, and regardless of how good the hash function is, collisions will always happen. What's collision? Collision means that multiple keys can map to the same index. Yeah, right. Okay, so you have learned how to deal with collisions. Okay, using a few different techniques. First of all, separate chaining. And then you have linear probing, modified linear probing, quadratic probing, double hashing. Okay. So we won't relearn hashing in 2010, but you expected to know it already, like I said, and you might need it. Okay, you might need it. Okay, in solving some of your PSs. So I expect you to know it. Okay, and you may have to compare and contrast it with binary search trees later on. Okay. Okay, so let's look at hash tables in VisualAlgo. Okay, so this is hash table I can create. For example, let's create a small hash table, 7, size 7. Okay, so it's empty. Okay, let's insert some number. Okay, let's insert 35. So in VisualAlgo, the key and the value is the same. So you just enter one value. That will be both the key and the value. Okay. So if I want to insert 35, where will we go? Okay. The hashing function for this is basically the division method. Okay, what's the division method? Just the key mod the size of your array, right? Yeah. So this one, size of my array is 7, right? So it's 35 mod 7 gives you 0. Yeah, so this will go into 0. So I'm using the separate chaining collision handling method. Okay, so add 35 okay, to the list at index 0. Okay, next insert. Okay, let's just populate it. Insert 36, it will go where? Index 1, right? And insert 37. Go index 2. Yeah. Okay, next if I insert 42, where will we go? 0, right? So 0, there's already something there, you just add it to the end of your list. Yeah. So this separate chaining. Okay. Okay, separate chaining, quite simple. Let's try linear probing. Okay, in this case, I already have some items already inside my hash table. Let's try to insert 42, yes. So 42 will go to index 0, right? But index 0, there's already something. So what happens? What should happen? Then you will just probe down the hash table, correct? Until you find an empty space. Yeah. So 42, 0, no, 1, no, 2, no, yeah. 3, empty space. So you put it at 3, index 3. Okay, so this is linear probing. Okay, you can remove an item. For example, I remove 21. Okay, so same thing, 21 will hash to 0, right? Then you'll find that at 0 is 14, so it's not the correct one. probe down the hash table again until you find it or you don't. Okay, so I find it index 1, so I will just remove it. No, mark it as deleted. Okay, you cannot remove it like that because later on you'll find that you might have errors when you try to search for other things. Yeah, if you just remove it and then there's a gap there, right? Okay, you can't remember, go back and review your hashing. Yeah, so you must just set it to deleted. There's something there, but it's marked as deleted. Okay. Okay, so you can explore hash tables and hashing on your own. Okay, let's go back. Okay, so it's very quick review. So basically go through your 1020 stuff. Okay, you can review the 1020 questions using the online training. Okay, just click on this link. Okay, yes, so here is some of the training questions for 1020 material. Okay, it says singly linked list below represents a stack where st.peak equals to 47. Suppose the following operations are performed. st.pop, what is the output of st.peak? Select no answer if the program results in error. Okay, what? st.pop, st.peak? What do you have? No answer? No answer. Okay, next one. How many comparisons required to sort an array? Blah, 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 blah. Okay. Okay. What is time complexity for each pseudocode? Okay. I'm just going to speed through it, okay, because I will show something else. Okay, so something, okay. Just enter any, enter something. Consider linear probe, okay, something, I don't know what is it. Okay, consider for each pseudocode, what is the output, okay. Something. Okay, singly linked this, okay. Oops. Okay. Next, finish already. So after you finish everything, just click submit quiz. Yeah, I got 1 out of 7 correct. Last semester I tried it random, I got 2 out of 7 correct. Okay, luck. Okay, what I'll show is this. After you have clicked submit, you'll see your score. You can actually check your answers. Okay, click check your answers. It will tell you whether you've answered correctly. Okay, I answered the first one correctly, right? Yeah, I spent time on this one. Okay, then, second one, answer wrongly, it will tell you what's the correct answer. Okay, so you can use this to train yourself, okay, on these more basic to intermediate questions, okay, on the training mode. Okay, so let's come back. Okay, now let's talk about the content for 2010. Okay, now I've done with 1020. Okay, now you all should be expert in 1020 already. Okay. Let's talk about the material in 2010. Okay, from the perspective of different problem-solving paradigms. Okay, that you will be using. Okay, that you'll be encountering in this course. Okay, some of these problem-solving paradigms you have already learned in 1020. Okay, some of it you will learn in this course. Okay. So let me just use an example to sort of demonstrate all these problem-solving paradigms. Okay, the first one is complete search. Okay, so here I'm given an array A. Okay, with the items 10, 7, 3, 5, 8, 2, 9. So there are 7 items, n is equal to 7. Find the largest and smallest element in A. How will you do it? Many ways of doing it, right? So, what is an efficient way of doing it? Notice that this array is not sorted, right? So I want to find the largest and smallest element. How will you do it? Yes? Anybody? How will you do it? Correct answer, wrong answer here, no marks deducted anyway. So you can just give me any answer. Yes, yes. Somebody. Yes. Okay, yes. Just one pass go through your array, right? Yeah. Keep track of a running minimum and the running maximum, correct? So if your current item that you encounter is small and the running minimum, update your minimum, right? If it is larger than your current maximum, the running maximum, update your maximum. So one pass through your array, I will find the smallest and largest number, right? Okay? So this is ON time, yeah, ON time, linear search. Okay? So this is complete search. Why is it complete search? Because the question asks for finding the smallest and largest element, right? So I search through the entire array, right? So this is complete search. Okay? So I think that the complete search that you think of when you think of complete search, right, in 1020 is basically a complete search takes a lot of time. Right? It's exponential time. Okay, but that depends on the question that's being asked. Here I'm just trying to find the largest and smallest element. Okay. So one pass through it, a complete search of your array, I find it. That is ON time. This is complete search. Okay, next. Divide and conquer. Okay, given an integer array A. Okay, now I have 10, 7, 3, 5, 8, 2, 9, and then more stuff at the back. So I have about 100,000 items. What is the 12,345th smallest item in A? Yes, yes. Wow, you got the answer for this one already. Okay. Okay. So, have you all heard his answer? Or do you understand his answer? Okay. Let me try to describe the answer if you try to do complete search. You try to do complete search, how will you do it? Okay, another way, the simpler way is sort everything, right? Sort it and then just go to index 1, 2, 3, 4, 5. Right? Imagine it's one base indexing. Just go to index 1, 2, 3, 4, 5. That's the element I want, right? Sorting. But, okay, disregard sorting. Disregard sorting. I do complete search, how will you do it? Apply the same technique for the first question. I find the smallest item, right? I remove it, correct? Then find the smallest, again, right? So it's linear, find the smallest, next smallest. Do this what, how many times? 1,200, 12,345 times, right? Then I must have found the item that I want. Right? But it takes a lot of time, right? Yes? Or the other way, yes? Sort it. Yeah? But sorting is the O(n) log n, right? The best you have for comparison-based sorting. Yeah. So another way is this. Okay. Another way is this. Pen. Okay. You use the partitioning algorithm of quicksort. Okay. Use the partitioning algorithm. Okay. Let's just use the one that you know. I pick 10. Okay. I pick 10 as the pivot item. Correct. So after I pick 10. Then the partitioning will partition all the rest of the items, right? Okay. The left side are those that are smaller than 10. The right side, those that are bigger than 10, right? Right. Then 10 must be in its correct position. Okay, imagine the index of 10 is k. Okay. Then you check whether k is 1, 2, 3, 4, 5, correct? If it is 1, 2, 3, 4, 5 means that 10 is the item I want, right? What if k is not 1, 2, 3, 4, 5? Yeah, if k is bigger than 1, 2, 3, 4, 5, then where can the 1, 2, 3, 4, 5 smallest item be? If k is bigger, it can only be here, right? In the left partition, right? So, go to the left partition, do the same thing, right? If k is smaller than 1, 2, 3, 4, 5, then the item I want can only be here, right? So, go to the right partition, do the same thing, yeah? So basically this is a divide and conquer algorithm. Right? Because first you partition it using the pivot. That's the divide part. Then I just conquer the partition that I want. I keep doing this. Okay? What's the time complexity of this? Yes. Yes. Okay. That's right. So basically the analysis for this is that the time complexity is just ON. Yes. Let me just remove it. Okay. Oh, wait. Oh, I kind of disappeared. Okay, let me just go back. Okay. So I said previous complete search not very good. Okay, then I described using the pivot algorithm to actually solve it. Okay, and the time taken is ON. Okay, why is it ON? Okay, this one we will explain it in tutorial 1. Okay, why is ON? Okay. Sorry? It's expected time ON. Yeah. No, if you do random pivoting, then it's expected time ON. Yeah. Okay. Anyway, let's go to the next one. Again, the next problem solving paradigm that you know is greedy. Okay. Same thing, I have an array A, 10, 7, 3, 5, 8, 2, 9, and more. Okay, still 100,000 items. Now, I want to find the largest gap G such that x, y is the element of A and G is equal to the absolute difference of x and y. Okay. So how do I find an xy that gives me this largest G? How will we do it? Can we do complete search? How will you do complete search in this case? Sorry? That's not complete search. Your idea is actually greedy. What's complete search in this case? Complete search is I generate all possible pairs of numbers, right, in A, right? And for each pair, I just compute the absolute difference, right? Then keep track of the pair that gives me the largest gap G, right? But then if I want to do that, that is at least ON squared, right? Because I want to generate all possible pairs. Okay? But you will notice that mathematically speaking, which one will give you the largest gap? Find the largest item, find the smallest item. Their difference will give me the largest gap, right? So then it's very simple, right? Just do what I did. Find the largest, find the smallest ON time. Boom. Yeah, so this is greedy. It's called greedy. Why? Because there is a way, there's a shortcut to do it, okay, based on mathematics. Okay? So this is called greedy. Okay? You don't have to generate all possible solutions. Okay? Okay, next, dynamic programming. Okay, here again, integer array A. Okay, you have 10, 7, 3, 5, 8, 2, 9, and so on and so forth. Only 1,000 items. Okay, n is 1,000. What is the longest subsequence of A? If viewed from left to right, it's always non-decreasing. Okay, so you want to find the longest subsequence of A that if viewed from left to right is always non-decreasing. Okay. So for example, 358 is a subsequence. It's non-decreasing, right? 3582, it's a subsequence, but from A to 2 it decreases, right? So yeah, this is not a valid answer, right? Then I have 3589. Okay, subsequence you can skip. Okay, they need not be contiguous. Okay, so I can have 3589. Okay, 3589 is the longest subsequence, increasing subsequence, non-decreasing subsequence. Okay, that you've seen so far. If I ignore all the items, okay, beyond 9. Okay. Yes, think about that. Think about that. Okay. Anyway, do you think that the complete search will work for this one? Will work lah. Complete search always work one. Complete search always work. But how will you do complete search on this one? How will you do complete search? That's the thing I always tell my students. Don't think about the most efficient one first. Think about the most inefficient one first. What is complete search here? Generate all possible subsets, right, of this array A, right? Then for each subset, I just check whether it's increasing or not, non-decreasing, right? And keep track of the longest non-decreasing one. But this is like computing the power set of a set of numbers, right? Which is what? How many subsets do you have? If you have n items in your set, you have 2 to the power of n, right? 2 to the power of n subsets. So basically, your solution is at least big O of 2 to the power of n exponential already. So the complete search for this one is, no, won't work. Won't work as in, okay, it will work, but then it's just totally inefficient. Yeah. Okay, so how will you do it? There's something called dynamic programming. Yeah, I won't describe it here. Yeah, I won't. I will have to take 3 hours at least, or 4 hours. Okay, so you need dynamic programming to solve this, and you can do it in just O n squared time. Okay, but it's also possible to do it in O n log n time. Okay, a more efficient version of dynamic programming. Okay, so this one we'll discuss in lecture 10 when you come to dynamic programming. Okay. Okay, so we have looked at the 4 different problem-solving paradigms. Okay, complete search, divide, conquer, greedy, and dynamic programming. Okay, so let's look at what you will learn and then which paradigm they fall under. Okay, for lecture 2, which is next week, you'll learn the heap data structure. So this is basically a divide and conquer paradigm. Okay. Next, lecture 3 and 4, you will learn binary search trees and the ADL trees, which are balanced binary search trees. Yet another divide and conquer paradigm. Okay, next lecture 5, you will learn some more data structures. Okay, union, find, disjoint set, basic graph data structures. Okay, your quiz 1 will be up to here. Okay, so lecture 1 to 5. Okay, lecture 6, you will do graph traversal. Okay, basically you'll do breadth search, depth search. Okay, these 2 classic graph traversal algorithms and the applications. Okay, you can classify them as complete search. Next, lecture 7, you will do minimum spanning trees or find the minimum spanning tree of a graph. Okay, we will look at 2 algorithms to do it. Both are greedy algorithms. Okay. Next, lecture 8 and 9, we'll be looking at the single source shortest path problem. Okay, you'll look at 2 algorithms, Bellman-Ford, which can be considered dynamic programming, and Dijkstra, which is a greedy algorithm. So quiz 2 will be up to here. Okay. And finally, the last stretch, lecture 10 to 12, okay, lecture 10 to 12, is basically dynamic programming. Okay, you will learn algorithms on the DAG, which is how you can view dynamic programming. You will learn classical dynamic programming, and then you'll learn all path shortest path. And final exam will be until here. Okay, and lecture 13 is basically just a review lecture. Okay, plus maybe a special topic which won't be tested. Okay, so basically that's the overview of the content, okay, for 2010. Okay, so that's all for today. Okay, let's gear up for the first topic next week, which is the binary heap, okay, or priority queue. Okay, please review your 1020 material at home if you have forgotten. Okay, so okay, that's it for this lecture. Thank you. Let me just close it first.